Hello, my name is John Geis. This presentation will cover three different ways of expressing milk of various components in a single number, total equivalent pounds of milk. The three methods to be discussed are fat-corrected milk, energy-corrected milk, and revenue-corrected milk. The original concept for corrected milk was to show the impact of higher milk fat on providing additional calories. This is referred to as fat-corrected milk. Because milk fat has more calories per pound than any other milk component, when the fat percentage is high, it contributes a lot of calories to the milk. This concept was later expanded to include value for the higher levels of protein. This is referred to as energy-corrected milk. More recently, models have been developed using economic value to correct milk. In this discussion, this is referred to as revenue-corrected milk. These calculations can be done automatically on the MilkPay website and apps, which will also be discussed. The term corrected implies that the actual milk quantity is not correct. This is not the intent of corrected milk calculations, and the corrections really just express milk in terms of an equivalent value of standardized milk. Corrected means that the milk components are valued on a common basis and expressed in terms of equivalent milk, using the standardized percentages of the components. To do this, a single parameter that is quantifiable for all components is needed. This is typically calories or dollars. The USDA Class and Component pricing use milk fat that is standardized at 3.5%, protein at 3%, and other solids at 5.7%. These values will be used to standardize milk in this presentation. They are also used in the calculations for the MilkPay website and app. As mentioned, a common basis that can be used to quantify all components is calories, energy, or dollars. If it is calories or dollars, the quantity of each component is measured in terms of its caloric or dollar value. The value of the individual components are then added together to a single total value for the milk. With fat-corrected milk and energy-corrected milk, this is then expressed as a quantity of milk that has the same number of calories, but with a defined percentage of components. In all cases, the equivalent value of energy can be expressed in one simple index, milk equivalent. An example would be to equate 80 pounds of milk at 3.7% fat to 82 pounds of milk at 3.5% fat. If the basis is calories, the quantity of each component is measured in terms of its caloric value, and the caloric value of the individual components is then summed to give a single value. The formulas in this presentation and the MilkPay website and apps use the caloric value for each component based on the USDA caloric values for milk fat, protein, and lactose. If the basis is dollars, the quantity of each component is measured in terms of its financial value, and the financial value of the individual components is then summed to give a single value. The value of each component is the USDA Class 3 component price announced monthly. The corrected value is then expressed as a quantity of milk that has the same number of calories or dollars, but with a standardized percentage of components. As mentioned in these examples and in the MilkPay automated calculations, the standard is 3.5% fat, 3% protein, and 5.7% other solids. Both the fat-corrected milk and energy-corrected milk calculations are based on the energy value of the major individual components of milk and are expressed in equivalent pounds of standardized milk. Fat-corrected milk measures only changes in fat, which has the highest energy value of the components. Lower energy values are used for the remaining components, and the quantities of these components are assumed to never change. Only the value of changes in fat are measured. As an example, a pound of milk with 3.5% fat, 3% true protein, and 5% lactose would have about 288 calories. If that fat were 3.8%, the milk would have about 300 calories, 12 more. Only changes in fat are considered in the fat-corrected milk. If milk protein went to 3.2% from 3%, it would have no impact on the fat-corrected milk value. Energy-corrected milk measures the change in fat and protein based on their individual energy values, but all other solids are assumed to never change. Only changes in fat and protein are measured. Of course, protein has a much lower caloric value than fat. In fact, it is about half as many calories per pound. Compared to the fat-corrected milk calculations just discussed, energy-corrected milk that had 3.2% protein would have 304 calories, 4 more calories than the fat-corrected milk. In the final fat-corrected milk and energy-corrected milk calculations, the corrected numbers are expressed as pounds of corrected milk, but they are based on the caloric value. Revenue-corrected milk calculations are based on the economic value of all components. Like fat-corrected milk and energy-corrected milk, the result is expressed in equivalent pounds of standardized milk. The component values in this presentation and the MilkPay website and apps are based on the USDA Class 3 component values. These component values change each month when new federal milk marketing order prices are announced. Compared to fat-corrected milk or energy-corrected milk, please note that the changes in weighting among components are very different for revenue-corrected milk. Protein now has twice the weighted value of fat. The opposite are the relative values based on calories. As with fat-corrected milk and energy-corrected milk, revenue-corrected milk calculations express the value in equivalent pounds of milk. As mentioned in these examples in this presentation and in the MilkPay automated calculations, the standard is set at 3.5% fat, 3% true protein, and 5.7% other solids. As mentioned, fat-corrected milk considers only changes in fat. All solids not fat are given a value that never changes. Fat has the highest energy value and has the most significant impact on the energy value of milk. In the formula at the bottom of this slide, protein is assumed to always be 3%, and the lactose in other solids is assumed to always be 5%. Energy-corrected milk is similar to fat-corrected milk, but considers changes in milk fat and protein. Because the same caloric value for fat is used in both fat-corrected milk and energy-corrected milk, the coefficient of 13.84 remains the same for fat. The remaining solid that has caloric value is lactose, and the quantity is assumed to remain at 5% in the energy-corrected milk formula. This results in the equation at the bottom of the page. In this example, 80 pounds of milk with 3.8% fat and 3.2% protein is calculated to contain 24,400 kilocalories. By the use of the energy-corrected milk formula on the prior slide, the energy-corrected milk would be 84.55 pounds of milk. The caloric value of the 84.55 pounds of energy-corrected milk, which has more milk but lower component percentages, is the same, 24,400 kilocalories, as the 80-pound milk. The revenue-corrected milk formula is the same in concept as the fat-corrected milk and energy-corrected milk formulas just reviewed. The one complicating factor is the changing financial value of components. As mentioned, the values used in the MilkPay website and apps are the current federal milk marketing order values for Class 3 components. This is the basis of payment for over 50% of the milk produced in the U.S. Revenue-corrected milk considers the financial value of the 3 components paid in the 6 federal milk marketing orders that pay on components. These prices change each month, which will change the value of the revenue-corrected milk. The formula for revenue-corrected milk is more complicated than the fat-corrected milk and energy-corrected milk formulas. The primary reason is that the value of the components, fat, protein, and other solids, are variables, not constants. Unlike the equations based on caloric value, which rarely change, the financial values change every month. For that reason, the MilkPay website and apps were designed to reduce the complexity of the calculation to minimal inputs. The current component values are always up to date on the website and can be updated in the apps with the push of a button. Which is better, fat-corrected milk, energy-corrected milk, or revenue-corrected milk? Milk standardized based on energy value, fat-corrected milk and energy-corrected milk, do not tell the producer the economic consequence of his choices. Only revenue-corrected milk, based on financial values, tells the producer the economic consequence of his choices. All of these corrected milk values serve a purpose and are in regular use in the dairy industry. Each suits a different need. Dairy is a business, and useful financial data helps those managing a dairy to maximize revenue and minimize cost. With this in mind, revenue-corrected milk is a better management tool than fat-corrected milk or energy-corrected milk. The following 4 charts illustrate the value of milk based on fat-corrected milk, energy-corrected milk, and revenue-corrected milk calculations. They use $1.50 per pound for milk fat, $3 per pound for milk protein, and 40 cents per pound for other solids. At these component values and the standardized component levels, this milk would have a Class 3 value of $16.56 per hundredweight. To more fully appreciate the differences between these forms of corrected milk, the next 4 slides will show the comparative difference between these tools. The charts will show the increased financial value of the milk using each of the corrected milk formulas. Each of these slides will show the value of fat-corrected milk in blue, the value of energy-corrected milk in red, and the value of revenue-corrected milk in green. By comparison, the actual financial increase is shown as a dashed line. In the first example, only milk protein is increased. The blue line at the bottom represents the value of the increase by the fat-corrected milk formula. Because the fat-corrected milk formula does not give value to anything except milk fat, it shows no increased value to the milk that has an increase in protein. The energy-corrected milk does show an increase in value, but it significantly undervalues the increase in financial value. This is because the components are given a value as a caloric contributor, and the protein does not have a high caloric value. However, it does have the highest financial value of any milk component. Revenue-corrected milk exactly matches the increased financial value. When only milk fat is increased, both fat-corrected milk and energy-corrected milk formulas calculate the same value. The red and blue lines are identical. Both also overstate the value of milk. Because fat has a very high caloric value, the equivalent pounds of fat and energy-corrected milk show a high value. Financially, the milk is worth significantly less. In this chart, milk fat and protein are both increasing. The fat-corrected milk shows the least value because the increased protein is not given any value. The energy-corrected milk shows a higher value than the fat-corrected milk. It still understates the financial value of the milk. In this final chart, milk is increased by 2 pounds, and both milk fat and protein are increased equally. Again, fat-corrected milk and energy-corrected milk understate the financial value of the milk. In all cases, revenue-corrected milk exactly calculates the value of the increased milk volume, fat, and protein. Calculating fat-corrected milk, energy-corrected milk, and revenue-corrected milk can be very time-consuming. The MilkPay website and apps can significantly simplify this. Simply let the application do the calculation.